Oh, good. So, hello, welcome everybody. We are going to talk today about how to build IoT services and projects using a platform called Lhings and Open Hardware. So, to start, you may be wondering who the heck are these guys. So I present myself. My name is Jose Antonio. I have a PhD in physics, but I moved later. It was funny physics, but I enjoyed more working with computers, and I started working in ICT. I work now for Lhings Technologies, that is the company behind Lhings, and I do mainly Java, EE, and embedded programming. And well, you have here our blog and my Twitter account if you want to follow me.
Okay, thanks, José Antonio. I'm José Pereda. I'm from the University of Valladolid in Spain. And I'm also related to JavaFX and embedded stuff. In fact, maybe some of you were yesterday in another section I gave with Mac Heckler about embedded stuff. And well, the reason why I'm here with him is just because we know from my university and his company in Barcelona, and I've been working with them for a few months, and I have my expertise in embedded stuff, Raspberry Pi, Arduino, and so on, and I would like to share with him my experience, and I would like to ask him about some things and why is Lhings platform really interesting for the stuff I do, for instance. So there is my blog. I blog about JavaFX and Embed and Raspberry Pi, Arduino, and so on, and my Twitter handle also.
So as I said, I come from a company called Lhings, which mainly market products and develops products connected to the internet and adds value to those products by connecting them to the internet. And the main product is Lhings. It's a cloud platform that we use to provide connectivity to all kinds of devices, and it's the main product of Lhings. So we start with the presentation itself. And well, the point is that when we want to make an Internet of Things project, we need some ingredients. Those ingredients are, well, of course, devices like Arduinos, Raspberry Pis, BeagleBones, whatever. Also sensors, thermometers, presence sensors, and many more. Also actuators. Well, we need some ingredients and also some preparation. We need to design our circuits and build them. We have to deal with low-level embedded programming. We have to deal with a lot of hardware issues. And also, as we're working with an Internet of Things application, we need to deal with a lot of networking issues, with communications through the Internet, and program all our networking code so that our devices connect to each other through the Internet. So the point is that we have to deal with many issues like the ones I show here. For example, security, because we do not want to that other people control our devices or get access to our devices if we do not allow them to do it. Also, it's a problem networking issues because we have to deal with firewalls. We have to open ports on residential routers.
Sorry to interrupt you. Do you mean, for instance, I've got my Raspberry Pi at home?
Yeah.
And I was here yesterday trying to connect to them. So I have to enable the port with BNC and SSH connections.
It's just
so
yeah.
I don't need to do that?
Yeah, with Lhings, you do not need to configure your router or open ports on your firewall because it automatically managed to get through the firewall router because the ability to push from the server is out of the box.
Okay, thank you. So, because that's good, because I have a bad experience about that. because just when I opened the BNC port, which is a regular port, the next day I couldn't get into the Raspberry Pi. Because
why?
Because the server blocked me and says, too many attempts. Okay, come on, the password is all right, it's just my first attempt today. And then checking the logs, I just found out I have 2 bots, one from Chile and one from Belgium, trying to get into my Raspberry Pi.
Really?
Sure. So if I don't need to open the ports or my router, my firewall, that would be great.
Yeah, because in that way you have less exposure also.
Sure, sure.
And well, also, besides these security and networking issues, we have the problem, what if we want to connect hundreds of devices and not only 1 or 2 or 3? So with Lhings it's also easy to scale. We have to take into account when working in a big project how to scale the message routing, the management of hundreds of devices. So also reliability. If you're going to market your products, you need that your network is very reliable, so that your customers do not, their devices do not stop working because of networking problems, right? So the point is that we have to write a lot of boilerplate code to get the connectivity right. But that is not what our devices do. We need to do it to connect them, but it's something that we have to do, but makes us, forces us to put the focus in something that is not what really our projects are about. So we end up writing a lot of networking code to make it work. That makes that you have exceptions, you have to do a lot of debugging, and finally that increases costs, longer time to market, not to mention that we may go nuts in the process. So what if we could do it in another way, getting rid of all the networking code and focusing only on what our devices really do? This is where Lhings comes in. Lhings is a cloud platform that allows you to connect, manage, and control your devices easily from the internet, and you can. It also provides a set of libraries and APIs so that you can set up your connectivity without worrying about the gory details of networking. So
let me ask you. If I have devices at home,
yeah.
So how should I proceed? How, if I want to put some sensors, how the values go to the server, or can I access to these values on the server? Or if I want to trigger some action, so if, for instance, I have a temperature sensor and the temperature value rises above some value, what can I do?
Well, the main thing we have to take into account with working with Lhings is that Lhings abstracts the concept of device around 3 main concepts. These concepts are the actions, that is what your device or devices can do. Also the events that can be sent by your device, that is what your device can tell about it or its environment, about what is happening in that very moment, and also that your device has a status. So for example, an action can be turning on and off a light. An event could be the one you mentioned, the temperature of some sensor going above a given threshold, and the status could be the very temperature of the device. So this is something important that we have to bear in mind when working with Lhings. These 3 concepts of actions, events, and statuses. A device is something that has actions, can send events, and have some status. And there is a 4th concept in Lhings, because you do not want your device to be alone in the world. You want to connect it to other devices. And we, in Lhings, do it through the concept of rule. A rule is mainly It is basically that a device X sends an event A, and when that happens, Lhings triggers action B on device Y. And we configure all these kind of rules through the web interface of Lhings, and also through it can be done through the REST API we have.
So let me ask you something. With that, do you mean that I can communicate different devices with different protocols? They don't need to understand each other at all?
Yeah, right. Right. In fact, here we are going to show how to connect a Hue lamp from Philips with a temperature sensor, and well, in principle they should not be communicating because they do not understand each other. In fact, with Lhings, they even do not need to know about each other because Lhings take care of all of that. So we are going to show here a simple toy example that is the excuse to show you how to program with the Lhings Java library. We have a temperature sensor, also a Hue bulb from Philips, and a fan. The idea is like, for example, you have the temperature sensor at home and the Hue lamp at your office, and you want, for example, to know visually if your home is hot or not. Mm-hmm. So when the temperature rises, the lamp gets red, and when it cools down, the lamp gets blue, right? Our setup is also quite simple. We're using an Arduino board with a proto shield to put all our circuitry regarding the temperature sensor.
Just let me know if most of you know about Arduino. I guess so. But do you have Arduino at home? How many of you? Okay. Do you know Raspberry Pi? I guess so too. How many? Okay.
Wow.
Great. Great. Have you played with Arduino and Raspberry Pi at a time? Okay, great. So I have here a few devices just if you want to check. This is the Arduino Mega, which is kind of the double size of the Arduino Uno. And
is the one we're using it in the demo?
This is just another Arduino One with an Ethernet shield above, because I guess if you have to go to the cloud, you need to be connected.
Yeah, you need an Ethernet shield or a Wi-Fi shield.
Okay, because Arduino lacks of Wi-Fi or Ethernet, so you need to buy a shield like this, which is quite expensive.
Or the Arduino Ethernet that has it out of the box. With the Raspberry Pi, is even easier because it already has an Ethernet port. So. And well, then we have here the Raspberry Pi that is going to command the color of the Hue bulb, and also will turn on and off the fan. And the idea is that when the Arduino will send the temperature reading through Lhings, and Lhings to the Raspberry Pi in order that the Raspberry Pi can set the color of the bulb. So, to wrap up, we said in Lhings the three most important concepts are events, status, and actions. So let's briefly see which events and actions and status we have in each device. In the Arduino board we have three events. One is the temperature event that will send continuously temperature readings to the cloud platform. And then we have two events, the above threshold event and the below threshold event, that will be sent whenever the temperature rises above or drops below a given threshold. In our example, the threshold is 30 degrees Celsius. So with the Raspberry Pi, we have 5 actions: turn on Hue, turn off Hue, the same with the fan, and also the set color action. And now we can proceed with the live demo. So let's do live demo. So let's do some code here. Well, we connect to the Raspberry Pi using SSH. So we can program them directly. We use, for those curious, a Raspbian version of the operating system for the Raspberry Pi. We are going to, let me tell you something, we are going to control the fan using relays. So we'll need to access the GPIOs in the Raspberry Pi, and we're going to do that using the P4J library. To get access at low level to the hardware, we need to be root. So the first thing we have to do is to become root, and then we can start coding.
Just to be clear, you are using Java,
yeah,
the Raspbian distribution, and you are using the P4J, sorry.
Yeah, P4J.
To access the GPIO pins, and you have the relays here on a seal.
Yeah.
So you can access and switch on or switch off the fan. Okay.
The fan. Yeah.
Okay.
Right. And we are also using the JDK7. That is the one that comes out of the box with Raspbian. Okay. So we go to this folder. Well. We need to use to program in Java with Lhings. We need to download some libraries, mainly this library that is Java for Lhings jar. It's our library, the library that allows you to connect to the Lhings platform. And then the dependencies that are all these jars here. For P4J, we also have the libraries installed in the operating system. Is something that we did previously. So we can start coding, and let's code our first device using Lhings. So we're going to use this editor. Well, and here it is, the code. So to start working with the library.
So just because maybe they should know, this is all the code, or you are going to do some live coding there?
This is this is the code, but the most important bits of code we need to program with the Lhings library are left out.
Okay.
So the most boring parts of the code are already there, okay, and we are going to see the most important.
So do you mean because I guess we don't have time enough to do from the scratch? But then, if they want to try, I guess the demo will be online.
Yeah, in fact, it's the code is already on GitHub. I will give you there the URL of our Lhings account in GitHub, and you could download the examples and play with the code.
The library is also available there.
The libraries are also available there, not only the Java library, but also the library for Arduino and a bunch of other devices. So the idea is that here we are going to code the most relevant parts of the code to get a taste of what is working with the Lhings Java library. So the first thing we have to do is, of course, importing the library. It's this simple line of code, and then we have also to import the P4J libraries. Okay, that's correct, it seems. Then we can start with writing our device. The point is that to make a device with Java for using the Java library of Lhings, we have to extend our class. The class that implements our device have to extend the Lhings device class. So once we do this, we should know also that to use Lhings, you have to have an account on Lhings. So we have to provide the library with the details of our credentials to access the platform.
Okay, so just if you want to write it, if they want to try at home when they have time to do that, do they need an account on Lhings, or they need credentials? How can they get that?
Well, to work with Lhings, you need an account. Currently, Lhings is in closed beta stage, but we are giving invitations, and I have a lot of them here. So at the end, if you want, you can come here, and I will be very pleased to give you invitations for you and any of your friends or colleagues that may want to try Lhings out. So to give the credentials to the library, we need to pass 4 parameters to the super constructor of the class, and they are the username, in this case is test, the password, in this case is also test, very originally chosen, and then the port we want to use to communicate from the Raspberry Pi, in this case, 5000, it could be whatever port is available, and finally you provide a name to your device. We are going to call it Raspberry Controller. This name is the name when you enter the Lhings web interface, your device will be identified with this name so that you can know easily which one it is. So now let's go the library. When you implement, when you extend Lhings device, you have to override 2 methods. That is, this mimics the syntax we use in Arduino. You have a one setup method and one loop method. In setup, you do all your initialization. Here we are using this P4J library to control GPIOs, and we have this pin digital, this digital output pin called relay, and we're going to set up the pin in this initialization code so that we can use it to control our relays. Okay, so this is easily done in this way. Using this method of the P4J library, and we pass here which pin we want to provision. In this case is the GPIO 6, an optional name, and finally the state in which we want the library to start the pin. In this case, we want the pin in its low state, so pin state low. So this should be good, and you
can set up more than one device with the same Raspberry Pi.
Yeah, but currently there is a limitation that only one device can be executed per JVM. So one JVM, one device is something that maybe in future releases we get rid of this limitation. So then in the loop method you can put all the code that needs to be executed continuously. The library will call the loop method continuously. Here we have a sleep so that we do not have a busy wait keeping all the resources of our processor. And finally we get to the most funny part, that is how we control, how we program an action for our device. In principle, it's very easy. We have to program a method that does the job, and for example, all the actions. The method to program the action should be a public void method. In this case, we are going to program the method that turns the fan on. To turn the fan on, we have to put the relay pin in its high state of voltage. So we do that using the P4J library. And in this case, it's a method without parameters. We put here the command to do the method to do that. Is this one. And also, as we have a status related to the state of the fan, we set this variable here to true. And then we have programmed the logic that does the action.
So how does the server know what method has to execute?
That's the point. So now, if we want to tell the library that this method is an action and which action it is, we use annotations for that. And it's as simple as annotating the method with action and provide here the name of the action. In this case, we can call it fan-on, a description that will show up in the Lhings interface, and optional parameters. The parameters, the actions could take any number of parameters. We should specify the which are the arguments. For example, if we have here an int, we would specify in the argument names that we have a variable called foo, and then Lhings with send all those parameters to this method. In this case, it's parameterless, so we don't need to do that. With this, the action is coded. So when we run our program, the library will search for actions and will send a small descriptor to Lhings telling, well, this device has actions A, B, and C, events C, D, and F, and these statuses. Okay, so we have also here another action to turn the fan off. Here the statuses are annotated with this other annotation, and we also provide the name of the status and the type that it should return.
So let me ask you. This is okay. The actions are executed by the server, so the server go to the method and choose that with the annotation, and the stats or the status of the variable, it's sent to the server, or the server pick it. How is it?
Yeah,
done?
the idea is that the server knows that this device has, for example, a status called is fan on. Whenever the server wants to know about the status of this status, it may ask the device, well, is fan on? And the device will return by calling this method. So it will return true or false depending if the fan is
so
on.
You're not sending
or
every
off.
second or every.
Yeah, it's not a polling mechanism, so it's like server pushing the request to the device, and then you get the value of the status. And finally, we also have here the actions for controlling the hue. We have encapsulated all the magic of changing the color of the hue in this method for the sake of simplicity, but basically it's calling a web service with an appropriate payload so that we can change the color of the hue. And the point here is that this set color action is the one that we are going to use to change the color of the lamp using the temperature sent by the Arduino board. If you remember from what we told previously, the Arduino board will send an event called temp event. That events can carry with them some payload, some information, and using this annotation here, we're telling the Java library that we want the library to put the payload of the event in this variable, in this string here, so that we can then later use it for whatever we want. Is the way the information sent by the Arduino reaches our action here.
Okay.
So it should be done. Now we save and it should compile. We are going to use Ant to compile it.
So you are compiling on the Raspberry Pi. No?
Yeah, we are compiling inside the Raspberry Pi.
I guess we can do that on our PC or our computer and send that to...
In fact, you can do it with NetBeans version 8,
Sure.
right?
So there is a great tool now in NetBeans 8, in this beta NetBeans 8. So you can just connect your Raspberry Pi to the network and just add a remote platform in NetBeans, and you just compile. Even you can debug on your computer. So that's a great tool because maybe
you
can
have
compile a small project, but a big project in Raspberry Pi may take some time.
It's difficult, and here I'm using Nano to code, but it's much more pleasant to use NetBeans for sure. So now the build was successful. Now we're ready to launch our device, and we are now going to see the Lhings web interface and what it provides. While it's launching, I'm going to show you a bit the code we have for the Arduino. It uses also the Lhings library for Arduino. I'm not going to enter into details, but basically you have also a list of actions, a list of events, and a list of statuses. And you have some commands you can use to send the devices, the events, whenever you want. The function is similar to the Java library, but okay, with the limitations of programming in C instead of Java. Okay, so hopefully our device is working. And now we are going to enter the Lhings web interface. Is this one. So we use the user test with our password, and we should see now this dashboard here with all the devices we have. 2 of them are online, and and many other things. I'm not going to enter into detail now. So I'm going to tell me.
How do you know which devices are online?
Well, you go here to this. As you can see, you have 4 sections. Here is the dashboard. There is a brief glimpse of all your devices ecosystem. You have here also apps that there are connection with external services to Lhings. The rules, that is where you set up the rules we talked about before. And finally, devices, that is when you can know which your devices are online. So here the platform tells 2 of them are online, and we see here our Raspberry controller and our thermometer are online. Okay, so if we go to the thermometer, we can see the temperature here, that it was it is some of the stages we define in the Arduino. So here I will go to touch with my fingers. So temperature is now 24.4. I'm going to touch for a few seconds, and it should rise, 25.6.
I guess everybody can see at the end that the values, or is the font too small, okay?
So if we go to our Raspberry controller, we also have all the actions we program in our code. Bear in mind that this interface is automatically generated for you. You do not have to write any single line of HTML code or whatever. Once you specify in your code which actions, events, and status you have, the interface is automatically generated for you. We can, for example, turn the queue off. Oh, sorry. And it turns off. and we can put it on again. The same with the fan. Let's check if it works, because we couldn't check it before. Okay, it seems it works.
So,
and finally,
just to be clear,
tell me.
You are launching some actions from the cloud.
Yeah.
And you're acting through the Raspberry Pi, first with the relays enabling the fan.
Yeah.
And then with the JPO pins.
We control the fan with JPO pins,
okay, yes.
the relays.
And the lamp?
And the lamp is controlled using well, some kind of web service, yeah.
Web services due to the lamp. Okay.
Yeah.
Great.
So now we see that we can control and manage our devices, but there is more.
So how can you put both Arduino and Raspberry Pi working together without knowing each other and without talking in the same language?
Well, this is where rules come in.
Okay.
And here we have the section of rules. I'm going to delete this rule, that is the one we used before, so that you can know about it. Well, so
plenty of rules there.
Yeah, there are two rules. I'm going to explain them together which rules we have. So to create a rule, we go to the rules section, and here we can do it. To create a rule, as we said before, a rule is something that relates the events of some device with the actions in some other device. So first you select the device that generates the events. In this case, is our thermometer. The platform automatically shows you which events we have here. The event we are interested in is this temp event. That is the one that sends the temperature. And now, once we select them, we select the target device, the device that is going to perform the action. So in this case, it's the Raspberry controller. And we select also the action we want to trigger. In this case, it's the set color action. And we're done. We can now give a name to the rule. For example, this one. And create it. And now the rule is created.
So let me guess. What we are going to do is when the temperature event is sent by the Arduino to the server.
Yeah.
The server will send this value in terms of degrees.
Yeah.
To the Raspberry Pi.
Yeah.
The Raspberry Pi will send it to this web services here, so that the lamp could adapt to this color.
Yeah.
For that, there is a mapping
between the temperature and the color of the lamp.
Okay. Well, let's see, because
let's see, it's working. So finally, we have. Okay, thank you. We have these three rules here. I'm going to enable this one also. So the one we just created is this one that relates the temperature of the sensor with the color of the hue lamp. But we also have here another two that are when the thermometer sends the event below threshold, that is to say the temperature dropped down below a given threshold, then the Raspberry controller is going to use the action fan off. So the fan is going to be turned off. And the same when the temperature is above threshold. So we have these three rules. So the idea now is that if we hit the sensor, then the lamp should change color and the fan should start working when the temperature is above 30 degrees. I tried to do it with my fingers, but it's difficult to hit very much quickly the sensor with my fingers, so I'm going to use a lighter.
Could you put at the same time, could you see the status of the temperature?
Yeah, right.
The monitor.
We can, good idea. We're going to see the...
Because as far as the rules are enabled, they are ready to go whenever the event happens.
For some reason, the thermometer
is off.
is off.
Okay.
But the good thing is that plug in again, it should work. Well, no. Okay, maybe we load. Yeah. It should be, my fingers are not so scary.
It was working before, but now the...
Yeah, in fact, the lamp is blue because it was working a few seconds ago. So let's see if now loading again the sketch. Well, it seems it's good. Oh, what a pity. So the device have been connected too much time, so the API is telling that too many requests are being sent to the device. So how much time do we have?
It's 5 minutes.
5 minutes? Okay, let's do some magic here. I'm going to get another terminal.
You shouldn't see that, I guess.
Yeah. Okay.
Well, that's the thing that happens when you're live coding, so...
It's the demo effect.
Sure.
So the fun thing is that now you know we're using Redis, so unexpected bit of information. So let's try it again. We unplug it again. No, it seems it does not want to work.
Check again the monitor. Too many requests also there?
Yeah, too many requests. So, what a pity. Well, let's do something quite quickly.
Did you put another device?
Yeah, I'm going to do one.
New Mac or?
No, it's easier than that.
Copy everything, huh?
Yeah. I think this is enough. Sorry for this unexpected problem. Well, let's try this. And now we'll load again our sketch. Well, I think now it's working. So hopefully we will see a new device here.
Okay, there you go.
Yeah, okay, but now we have to delete the rule and create a new one for this device.
Okay, this is a new device, or it is the same?
It's in fact it's the same physical device, yeah. But what we have done is to delete the credentials it uses to connect to Lhings. So when we restarted it, it was created from scratch again, and we have to create the rules now again. So the thermometer with the temp event and the Raspberry controller with the set color event, and to be fast, I'm going to create only one of the other rules, the above threshold, the one related with the above threshold. So, for example, again, the thermometer, we select the above threshold event. Sometimes it lasts a bit to load the page, but it should be fine. So, in the end, okay. Well, and now the Raspberry controller with the fan on. So this rule will turn on fan when the temperature is about 30 degrees Celsius. We give it a name, create a rule, and where we should be ready to see it working. Let's cross fingers this time.
Check, go again to the status.
Yeah, to the device.
You can see the temperature already there.
The thermometer temperature is
25.
25. And now we hit it. Look at the lamp. It should be start getting red. Okay. The fan started working. So finally, we. Thank you. Thank you very much. Thank you very much.
So if I refresh now.
Yeah, we can refresh it. And we can see how the temperature drops. If we have the other rule, it will stop working at it reaching 30 degrees.
It's turning blue, isn't it?
It's turning blue, yeah.
Yes.
Yeah, it's getting blue with time.
Okay, that's great, because you are just communicating things quite different from my experience.
Yeah.
You have to provide IPAs, interfaces, talk the same language, do the same stuff. And it's quite difficult. I think this is a good way to go. I don't know if they
in fact,
the same, but
if you realize about it, we didn't wrote any single line of networking code, and all the devices are working together through the internet. They are connected to this DSL router that can be the one you use at home to connect to your internet provider. So is everything working fine? So finally, to wrap up in quite what we get. Well, as I said, we forgot completely about networking code. Also, we have security because all messages are encrypted through the platform, so we do not worry about security concerns. Also, networking is made very easy because we do not have to worry about opening ports or firewalls, etc. In fact, we can not only make the devices send information to the server, but also the server can push information to the devices. So it's very easy to control them remotely. And also you get automatically a web control panel for your devices. So once you write the code, you can start writing that moment, controlling them from the internet with your web browser. It's easy to scale because adding devices is like a breeze. And finally, you have the reliability of a platform that is used by a lot of people, is tested by a lot of people. So it has trustiness for bigger projects than this one, for example. And well, this is all, but I also want to thank you for your attention. Also, Jose Pereda, for being a great colleague here. And also, as I said, all the code is in github.com/links. And if you want to test Lhings, you can come here, and I will be very pleased to give you invitations to our beta version so that you can try it whenever you want. So thank you very much to all of you.